of finding out where any high spot is that you can plane off. You obviously can't add glass to a low spot. You have to plane off the high spots. And he gives a mathematical method of interpreting the surface that tells you where the high zones, the high rings are on the surface of your mirror. I shouldn't have left that there so long. I'll rotate it a bit more. Now this is 3 revolutions, right? Yeah. 3 times around the mirror. Getting a little bit stiff. A very interesting method of interpreting the coup-de mask readings to find out where the high areas are that have to be planed off. In this case, the edge area is very easy to see, but some of them are a little bit more tricky, especially as you start getting toward the end of the figuring of the paraboloid. And actually, for a faint high zone, all you need is 1 or 2 circuits around the mirror. You don't need to go around 10 times, so you'll take a huge gouge. Just once or twice, each figuring step only needs 1 or 2 circuits of the mirror, like 1 or 2 revolutions around the mirror, like I'm doing now, is plenty when you're removing a faint high spot, a very faint high spot that barely shows. Now what I'm going to do is just go a little bit further. Now what I'm going to do is just remember that right about there, toward that direction, is where I have to start polishing again. So you have to have a good memory when you're doing this. Okay? So what I'm going to do is just I think I'm just going to let it press for a minute and then add some fluid. I'll let you watch me for a little bit longer and then I'll shut the camera off. In fact, I think I'll shut it off now. Maybe just go around once more. I think you got the idea anyway. Yep, I think I'm just going to shut the camera. I can't think of too much more to say. There is one thing you could do. Just make sure that you know exactly where the high area is in the mirror. You might have to take a ruler and actually, without getting any contamination in the mirror, just measure it to get it. Like, say there's a high zone 3 inches in, exactly. The hump of the high zone, the highest part, is 3 inches in. Take a ruler and have a look at it so you can see just how far that is on the actual surface. You know, and then it'll give you an idea of exactly where to put the inside edge of the tool when you're planing it off. And remember that the pitch squares, the edges of the pitch squares are recessed in a little bit from the edge because they've been trimmed off. So that, like, they're actually about, see where this white edge of the tool is? The edge of the pitch squares is actually about 1/4 of an inch inward from that. So, actually, you have to keep that in mind when you're removing a high zone. And also, most of the polishing action, the heaviest won't take place likely at exactly the edge of the tool. It might be in, say, 1/4 or 1/2 an inch in. So, you have to remember that. There's all kinds of things. It takes a little bit of skill to do this. Not much, though. You can see it can be picked up pretty easily. It's not much different than a carpenter taking a plane and planing off the high spots on a wooden board. It's a very similar idea. It's really pretty easy once you get the hang of it. Add a little bit more of this stuff now. It's amazing, like I say, how quickly this stuff dries out. This is distilled water, by the way, mixed with the rouge. I didn't use ordinary tap water. This is distilled water that I'm using as a part of the ingredients here. In the still of the night. In the still of the night. Sorry about that, but it had to be said. By the way, you have to be careful and think about what you're doing when you're moving around, because all down on the floor, don't drop these polishing agents and stuff, because all down on the floor is grit left over from the rough grinding and stuff, which I haven't cleaned up. I put more newspapers down, but they do tend to get spread apart a little as you work. So the newspapers tend to cushion your feet against the action of the hard concrete floor too. Makes it a little easier to walk on, that a little bit more of a cushioning effect. A neighbor recommended that. As you can see, this barrel is quite strong. It stands up to a lot of stress. This board on the barrel that the mirror is bearing against is very flat, quite accurately flat. So it doesn't need a huge amount of newspapers to cushion it against the molded flat back of the mirror, which is quite flat. The back of the mirror is nice too. It's not fine ground, but it's sort of got a slightly wavy, polished surface. And you can see through it from the other side if need be. You can see what's happening. So that's nice too, you know. This will be probably my final large mirror that I ever make. It's quite, as you can see, it's quite a bit of physical work. I've been working on it. I started 2 years ago this month, grinding it. I think on the videotape you'll see I look a little older now, probably, than I did then. A little bit more ragged around the edges, because time goes by and people do get older. So I have to remember I start right in this position when I start up again, and when I get back to here, that'll be 4 revolutions around the mirror. So you could tell me if I've done anything wrong when you see the videotape, but I think I'm doing everything correctly, I hope. Well, it's time to, right now, I'm going to shut the camera off. I think I've talked enough, and I'm going to just concentrate on the actual process from now on. It's a barrel of laughs. I'll be showing you actual Foucault photographs. Texero calls them Foucault shadow. Actually, I pronounce it Foucault, but I think the right way is Foucault. But I catch myself doing Foucault once in a while. But Texero calls them Foucault shadowgrams. Isn't that a fascinating name? Foucault shadowgrams. Those are the photographs of the actual mirror under the Foucault test. And you'll be seeing some of those somewhere in the videotape, I'm not just sure where, to show what the shadows actually look like on the mirror. And I'll try and explain what a high zone looks like and that sort of thing. But I've taken a few photos with my digital camera, and I can convert those to video just by photographing them on the computer screen with the video camera. So anyway, I'm going to shut the camera off now, and working with rouge, as you can see, is a pleasure. It's really not what you call a hard physical job. I'll just say one more thing. Right now I'm at the finesse state of figuring the mirror. Up until now, when I was using the long strokes with a barn sight, I was in the brute force stage, which is basically true for rough grinding and for the polishing with the barn sight. And you might say fine grinding is sort of finesse because it's really not physically too difficult, although you're lifting the mirror off and on all the time. But as you can see with a tool, you just have to decenter it when you're putting new polishing agent and water on it. Well, here goes. I'm going to shut the camera off. I hope the finesse doesn't end in a mess. I hated to say that. I composed it instantly, spontaneously, and not very well. So with that happy note, I shall depart for now. Goodbye. I forgot to mention something when I was talking about the raised zone at the edge of the mirror right now. It has a longitudinal aberration relative to the smooth spherical central area. It has a longitudinal aberration of approximately 350 1/1000ths of an inch. I measure in thousandths of an inch on my micrometer. That's equal to approximately 1/3 of an inch, which is about the same as the longitudinal aberration of the entire paraboloid. Of course, the paraboloid will be in the opposite direction with the edge of the mirror getting longer radius of curvature. Right now it has a shorter radius of curvature. So it's really not that far out right now. It's pretty close to the ideal, considering the large size of the mirror. So it shouldn't be too much of a hassle to get reasonably close to the paraboloid using this method. But I thought I'd tell you it's approximately 350 1/1000ths of an inch in longitudinal aberration as measured with my micrometer and the Foucault test. I haven't used the Coude mask yet because I'm not at the stage where a great deal of finesse measurements over the whole surface are needed. So anyway, I'm just getting the longitudinal aberration more or less under control right now in the major zones. So anyway, I'll sign out again. I forgot to mention what the actual magnitude of the error that I'm trying to remove. Those of you who would like to do a calculation can figure out how many wavelengths that edge zone is departed from an actual sphere. Should be an interesting calculation. I haven't done it yet because I'm too lazy, but it would have been an interesting thing to try. Sorry to bother everybody again, but I just figured out, I think it's running now. I figured out a better way. Hey, yeah, it's rotating. I figured out a better way to get the stroke pattern how to switch to the next stroke pattern. Whoops, it's getting a little stiff here. I can just show you. Halfway, you make, instead of stopping at the end of the stroke like I did, move it back half up way and then turn it a little bit, and it'll automatically be in the position for the next set of 6 strokes. I'll show you what I mean. You can see it really well right from this angle. Okay? Start out doing 6 strokes like this. 2, 3, zigzagging, 4, 5, 6, very shallow. Now you start out about halfway there, and then just rotate it in just a little bit, and you'll be right in the position to start the next series of 6 strokes. 6, and then halfway down, now you're in the position to start the next 6. You can just rotate it just a little bit, instead of going right back to the beginning like I was doing, which is not very smart. See that? Halfway down, step around, rotate slightly, and I'm right in the position for the next 6 strokes. I don't know why I didn't think of that before. I'm getting old and senile. Beautiful, eh? I'll just complete a pattern while with the camera running. Halfway down, step around, rotate a little bit. Halfway down, rotate just a little bit, and I'm in the position for a new pattern. Oops, didn't go halfway there. Halfway, rotate around just a little bit, there I go. Halfway, rotate back a little. Now that's 5 circuits, I believe. Halfway. Like just a smidgen. Halfway. A little bit. Halfway. Rotate just a smidgen to get a little bit new angle on the tool. Okay, that's good. Now the next one will start due south. I think that's where the entire mirror grinding project is going, is due south. I see a flashing red light on my video camera, which I think means the tape is running low. So I'll see if it's still rotating. Yeah, the tape is still rotating, but there's not much left. So I'm glad that I was able to get in the programming what I did today. I hope this instruction means something to everybody. It will give you some insight into what goes on in making a mirror anyway. So that's very important to have. And this videotape, actually, to get it all in, I might have to use two tapes, like two-hour tapes, the final, VHS tapes, in order to get all this information in. But